Hello everyone, and welcome back to CALC 1. This is our first video in Section 1.2, which is on evaluating limits. We've already looked at limits in the sense of sort of getting an idea of what they mean and how you would figure out what one was just by looking at a graph or a table. But we're going to start in this section looking at calculating them using more mathematical or algebraic methods. And that's what we're going to look at in this video. We're going to be looking at evaluating limits without graphing or using tables. So that's our goal here. So what we're going to look at here is different types of functions, and we're going to find the limits based on what type of function we have. So there are actually several types of functions, some of which you haven't actually, we're not actually going to talk about in here. They are mentioned in your textbook in this section, but in this video we're not going to talk about all of them. We're going to talk about the two that have the limits that are the most easy to calculate. And one of these we're sort of going to get ahead of ourselves a little bit, and I'll start off with that one. Okay, so these two main types. The first one is functions that are defined at every point and don't have gaps or jumps. These functions are called continuous functions. We're going to deal with that specifically in Section 1.5, but the point here with these type of functions is their limits are easy to find, and all you have to do is plug in the value. In other words, you have functions that if you're looking at a graph of this function, you would just draw the graph. You never have to pick up your pencil. This is sort of the common way of describing a continuous function. You don't have to pick up your pencil to draw it. So you don't have any gaps, you don't have any jumps, you just draw a curve. And so what value the function is at is the same as the value it's approaching from either side. And because of that, limits of these kinds of functions are easy to find, and you just have to plug in. Okay. There are also functions that have undefined values, but are still relatively easy to find their limits. And not all functions with undefined values are like this, but we're going to look at some specific ones today. These functions are going to be distinguished by a couple things. Almost always you're going to have a 0 in the denominator. So you're going to have a 0 in the denominator. These are functions that are going to be undefined at a certain point. But if you have a 0 in the denominator, you're still going to be able to find the limit of the function. And that's what we're going to look at today. Well, sometimes you're going to be able to find the limit. Let me point out the difference here. Some of these functions still have undefined limits. So even though your function has a 0 in the denominator, you have two different options here. Sometimes they have undefined limits, and sometimes their limits actually have a value, even though the function doesn't. What will happen here, there are two things, essentially. Let me talk about them here. You can have essentially two different situations if you have a 0 on the denominator. if you plug in and get a 0 in the denominator, there are two different options. Sorry about that. That's Loki. He's squeaking his toy. I'm sorry about that. One option is we have a 0 over 0, and the other option is we have some other number over 0. I've just put a number sign there for that. So these are the two options here. If you have this second one, this second one here, a number sign over 0, that function, that limit is going to be undefined. That limit will be something that we don't actually have a numerical value for. So we will have, if you have a number over 0, that means this limit here is definitely undefined. Okay. This first one, on the other hand, sometimes is defined. It depends, though. Let me point this out here. Sometimes this one is defined. In other words, sometimes this exists. And the point of what you have to do here is you have to, in this first case here, where you have 0 over 0, you have to factor the top and the bottom and try canceling and then plugging in. And if you can plug in and get a value, then even though the function might not exist, the limit still would and would have that value. So essentially what you're going to be doing here is you're going to factor, cancel, and plug in. This other case here, this is undefined. We won't be able to really plug in. We sort of plug in to see that we get something, some number over 0, but you wind up with something that's undefined in the second case here. So this is undefined. Now we'll be able to talk a little bit more about that in a later section, about a way to describe this other than just as undefined. But that's where we're starting for now. Okay, so we're going to be looking at two cases here. One where we just have to plug in. In other words, you can plug in at any point, you get a value at any point. So that's one case of a function that we would look at its limit. And the other one is if we have something where we would plug in and we'd get a 0 on the denominator, then we're going to have to check what happens there. Okay, so what I want us to do first, we're going to look at this first example here. So you'll notice here, let me actually fix this up a little bit to write it out a little bit better. There, letters look separate there. Okay, so our function here is x cubed plus 2x minus 1. What I want you to do here is find the limit as x goes to 2 of f of x. I want you to find that. So I'm going to ask you to pause the video, try and do this. Remember, look at what type of function we have here and what that means about what you should do. Is this one where you're going to be able to plug in? Or is this one where you're going to have a 0 in the denominator and might have to cancel? So think about that, pause the video, work on it, and when you're done, restart the video and we'll go through it. Okay, so I assume everybody is back now. Let's take a look at this. Now you'll notice, if we look back at the descriptions of what we had before, functions that are defined at every point and don't have gaps or jumps, if you have this function here, this x cubed function, that's going to be one of these curve shapes that we see a lot of graphs, from a lot of graphs. This is cubic, generally starts low, goes up, and then goes up high, sometimes with a little bend in the middle. That's the general shape, but the important point about a cubic, and here any polynomial, so any polynomial is going to have this happen. So any function like this, where it's just sums of powers of x and the like, those are always going to be continuous. In other words, you're always just going to have to plug in to find the limit. These aren't the only functions that are like that, but these are some of the most basic ones. So let's go ahead and do this then. Now that we know all we have to do is plug in. So here I plug in x equals 2, so I should get 2. Let me zoom in a little bit. 2 cubed minus, wait, is it minus? Plus, sorry. Plus 2 times 2. And then minus 1. If we work this out, that then becomes eight plus 4 minus 1, which is 12 minus 1, or 11 as our answer. So when we have a polynomial or some other kinds of functions, and we'll talk more about an entire list of what those are later on, but any polynomial, you can just plug in the value for x to find the limit. And that's what we did here. Okay, hopefully that makes sense to everybody. Of course, you can always ask questions if you have them. All right, so next up, we are going to look at another function. Now, you might guess that our first function was a function that was defined at every point and didn't have gaps or jumps. So our next example is going to be a function that has values at which it's undefined. Okay, so functions that have values at which they're undefined. And in particular here, the ones we're interested in are ones with zeros in the denominator. So in order to make a function like that, we have to have a function with a denominator. So here is our denominator. Here is our numerator. So we have something where we could get a 0 in the denominator. If we have a 0 in the denominator, we can't just plug in. If we don't have a 0 in the denominator, it works just fine, right? So, oops. So, no 0 in the denominator. You just plug in. Okay, so if you don't get a 0 in the denominator, you just have to plug in like we did before. There's no confusion about that. If you do have a 0 in the denominator, just plugging in won't work. You do sort of have to try plugging in at first to see, do I get a 0 in the bottom? If you do, then you have to deal with how you can deal with what's left. Okay. So what I want you to do, one other thing. So if we get a 0 in the bottom, we should factor and cancel. So factor the top and the bottom and cancel. you can do that anyway. I mean, there's no harm in doing it in any event. In fact, that would probably be a good first step on this, is to factor both the top and the bottom to see what happens. But if you get a 0 in the bottom, you definitely need to factor the top and the bottom and cancel in order to be able to find out what the limit is. Because once you've canceled, then hopefully that gets rid of the 0 and you'll just be able to plug in. Okay, so I know that might be a little bit of a jump to have you do this on your own at this point, but what I'd like for you to do is pause this and try to find the answer of all three of these limits that I'm asking you to do. Okay, so pause the video, try to find all three of those, and you're going to find each of these is in a different case. We're dealing with different things in each of them. And when you're done, unpause the video and we'll work on them. Okay, I assume everyone is back. Let's go ahead and start with this first one. So, one thing we can do to start with here, and I'm going to do it this way, even though it might be worthwhile just to go ahead and factor the top and the bottom to begin with. Actually, let me do it this way. Let me make sure I put the limit stuff here. So we have limit x goes to 3 of x squared minus 4x plus 3 and x squared minus x minus 6. Okay. So, the first thing we might do here is just try plugging in. Now, there's no guarantee plugging in will work. If it does, if you get a value for a function like this, it's going to be the limit. If it gives you 0 over 0, then you're going to have to work on something else. So if we plug in 3 in the top here, we get 3 squared is 9, 4 times 3 is 12, so 9 minus 12 is 3, plus 3 is 0. So that would give us a 0 on top here. Now that's no problem just yet. 0 on top is okay, 0 on the bottom is a problem. Now on the bottom, 3 squared is again 9, minus 3, 9 minus 3 is 6, minus 6 is again 0. So what we get here is 0 over 0. So this is a situation where just plugging in doesn't work. And what we have to do then is we have to factor the top and the bottom. Now let me see if I have enough room here. I think I do. Let's go ahead and do it. Limit x approaches 3. So here you're going to have to go back to your algebra. You have to remember how to factor. So let's go ahead here. So this is like reverse FOIL, remember. Since we have x squared at the start of both of these, we're going to have x's in the front. Let me show you here. Since we have x squared as these first terms, we're going to have x's at the start of each of these. Like if it was 2x squared, we might have a 2x and an x. Now on the top, since this number is negative and this number is positive, that means both of the signs have to be minus. There are a bunch of rules like this, and it's good to go back and review them if you're having trouble remembering. So we need two negative numbers that multiply to give us 3 and add to give us negative 4. Well, those two are minus 3 and minus 1. So x minus 3 and x minus 1 factors from this. We can do the same thing in the bottom. Here, since both of those values in between the terms are negative, we're going to have one negative value and one positive value. So one's minus, one's plus. The negative has to be bigger. They have to multiply to give us 6. that's 3 and 2 here. You can FOIL these out to check, and it's a good idea if you're not sure to do that. Okay, so the point here is we have now x minus 3 times x minus 1 over x minus 3 times x minus 2. What you notice about this is we have the same factor in the top and the bottom. And when we do that, just plugging in a function value, we're not allowed to just cancel and say it's that. But for a limit, we are. So we can cancel these two factors, and then we get limit as x goes to 3. Now just x minus 1 over x plus 2. So we factored and now we can actually plug in. We don't get a 0 on the bottom anymore. We just get a number. So 3 minus 1 gives us 2 on top. 3 plus 2 gives us a 5 on the bottom. That is our solution, 2/5 here. And you'll notice getting 0 over 0 doesn't tell you at all what you're going to wind up with. You could wind up with 2/5, you could wind up with a whole number. It could be a negative number. 0 over 0 isn't telling you any of that. Okay. So hopefully that makes sense. If you need a chance to try the second one on your own, if you didn't go through it already, you can go ahead and pause the video again. Here in a second, I'm going to start working on that one. Okay, so this second one, we will notice that we don't have to go through the plugging in anymore. We can actually just go ahead. Well, I guess I will plug in here. But one thing I do want to notice here is when you're doing these, you can always, if you have this kind of rational function, so one polynomial on top, one polynomial on bottom, we call that a rational function. You can always cancel these out in limits. So I could just go through and do this like that again. Oh, I made a mistake there. That shouldn't be 3. That was a minus 2. Okay. But either way, when I plug this in, so if I plugged it in the original version, I would get, if I plug in negative 2 on the top, I get negative 2 squared, which is 4, minus 4 times negative 2, which is 8. So that's 4 plus 8 is 12, and that will give me a 15 on top. And on the bottom, if I plug in negative 2 squared is 4 again, minus negative 2 is plus 2, so that gives me 6, minus 6 is 0. That's what I would get if I plugged it into the original. If I plug it in here, what I get is going to be a little bit different, but it's not really going to matter. And let me show you why. So if I plug this in, negative 2 minus 1 gives me minus 3 on top. Negative 2 plus 2 gives me 0 on the bottom. You notice I didn't get the same fraction, but what I got shows me it doesn't matter exactly what fraction it is, because remember, hang on. What we said here is if we have a number that's not 0 on the top and 0 on the bottom, our limit is undefined. So this means this limit is undefined. Okay. So the fact that we had some number that wasn't 0 over 0 means that the canceling isn't going to help us. Okay, so that's what happens here. Hopefully that makes sense. Now, finally, we're going to do the last one. It's, again, the same function. You'll notice I'm using the same function 3 different times, and we're going to have 3 different kinds of processes and 3 different results here. So the last function, we're going to do the same function, but here we're going to let x go to 1. Now, if you haven't worked this one through, go ahead and pause it again, and I will come back and we'll talk it through. Okay, so here I have limit x goes to 1 of, what did I have on top? X squared minus 4x plus 3, and on the bottom, x squared minus x minus 6, I think. Wasn't that right? Yeah. Okay. Now, we can leave this alone, or we can factor it either way. Let's go ahead and I'll show you both versions here. If we factored and canceled, we've already seen what happens there. We get x minus 1 on top and x plus 2 on the bottom, right? So here we have 2 different versions of this. Either way, when we plug in, remember, you have to be a little careful on plugging in here, because if you get a 0 in the bottom, that doesn't mean that that's the limit. It means you have to do some more work. But either case here, if I plug in, if I plug 1 into the top of this first one here, right? If I plug 1 in there, I get 1 squared, which is 1, minus 4 times 1, so 1 minus 4, that's negative 3 plus 3, that gives me 0 on top. Okay, and at this point you're thinking, oh, we're going to get a 0 over 0, we'll have to do the whole factoring thing. Well, take a look here. If I plug 1 into the bottom, I get 1 squared, which is 1, minus 1, which is 0, minus 6, which gives me negative 6 on the bottom. So I get 0 over minus 6 there. Before we explain this, let's take a look at what we get if we've already canceled. If I plug 1 into the top, I get 1 minus 1, which is 0. If I plug 1 into the bottom, I get 1 plus 2, which is 3. So you will notice here, I get, these fractions don't have the same top and bottom, right? I do have a different bottom on each of these. But if we look back up here, we were told, or I guess I told you, whatever. If you have 0 over 0, you can factor and cancel and maybe get a limit. If you have a number over 0, the value is undefined. If you'll notice here, we don't have either of those situations here. We have 0 over a number. So we have to be careful and think about, what does that mean? Well, what does it mean if we take a fraction and have 0 on top and some other number on the bottom? Well, what you find is dividing 0 by anything, this isn't a problem like dividing by 0. This just gives you 0. So either one of these, the fact that the fraction looks different doesn't mean anything. These values are both equal to 0. So whether you factored or not, you get 0 as your answer, so that is our limit here. So you'll notice that we had this function here, this polynomial over a polynomial, and depending on what we were letting x approach, we had 3 different results. One time we had to cancel to get rid of the 0 on top and the bottom to get our number. The next time we had something over 0, some other number over 0, and that meant the limit was undefined. The next time we had just something we could plug in. Here it happened to be 0 on the top, but it wouldn't matter. If we can plug in and we don't get a 0 on the bottom, that becomes our limit. Okay, so hopefully this was helpful. I will be continuing to upload and post these videos and put the PDFs on your Moodle page as well. If you need anything, please contact me and let me know, and I'll talk to you again soon.